Today on Frame.
Mercedes-Benz Vision EQXX is a battery electric vehicle concept car by German carmaker Mercedes-Benz. EQXX is a proof of concept with the primary goal of having an autonomy greater than 6 miles per km. Its exterior features various stylistic cues that help maximize its aerodynamic efficiency, and various eco-friendly materials also adorn the interior. The car's name refers of Mercedes' vision for the future of automobile manufacturing, stating that the EQXX is how Mercedes imagines the future of electric cars. Initial design on the EQXX began in June 2020 after a request from the company board for an electric vesicle with 621 miles of range. In order to fulfill the request, Mercedes selected a team of specialized engineers from various departments. This team also collaborated with Mercedes Formula One engine manufacturing subsidiary Mercedes-AMG high-performance powertrains. For designing these kinds of vehicles, 3D modeling and visualization tools are essential to get an overview of how all components fit with each other. EQXX interior includes a neuromorphic computer system, which helps to drastically reduce the power consumption of components such as the infotainment system. To achieve the highest possible autonomy, the aerodynamic profile of the EQXX was refined using a wind tunnel. Wind tunnels help to visualize the interaction between the object and the surrounding airflow to predict its aerodynamics. One of the most interesting tests to carry out is a flow test, which allows one to see if the air has a laminar or turbulent flow along the vehicle profile. Additionally, with this test, the boundary layer detachment can also be studied, which gives valuable information to modify the surfaces of the vehicle. Results obtained from the wind tunnel are then compared with the CFD simulation outputs to improve the simulation conditions. It is also interesting to analyze how mobile aerodynamic elements, such as the diffuser, perform in wind tunnel tests. In order to increase the energy density of the powertrain, Mercedes also introduced a new method of packing the individual cells in the battery pack, called cell-to-pack. A silicon carbide inverter transmits the power from the battery packs to the radial flux motor located in the rear axle, which produces 201 horsepower. As a result of the powertrain optimizations, the EQXX is said to have a parasitic loss of only 5%, meaning a 95% energy efficiency. EQXX X has done 2 demonstration runs in which it surpassed the initial target of 621 miles, one from Sindelfingen to Cassis, and the other from Stuttgart to Silverstone. Although EQXX itself remains a single concept, several features, such as powertrain components and smart features, will be included in production models in 2025. Moving on to the Mercedes-Benz Bremen plant, mass production models such as the Mercedes EQC can be found. Mercedes-Benz EQC is a battery electric compact luxury crossover SUV produced by the German company since 2019. It was the first model of the Mercedes EQ family, which was unveiled in 2016 and currently includes over 10 models. Mercedes intends for the EQ models to represent around 25% of the company's global sales by 2025. One of the biggest concerns with electric vehicles today is safety, since batteries can easily catch fire and are difficult to put out. Therefore, strict crash tests and studies are carried out to figure out the best way of protecting the batteries. To study the results of a crash test, several crash stickers are placed alongside the vehicle since they can easily be tracked by cameras and sensors. Additionally, crash test dummies are usually placed inside the vehicle, which includes a set of sensors that measure the forces a passenger in that position would suffer. Another essential element in a crash test is the colliding structure, which needs to absorb the desired amount of energy from the crash. The collision environment must be adequately illuminated to allow the cameras and sensors to record high-quality images. Test vehicles are equipped with a large number of sensors that record all the forces, interiors, temperatures, and other parameters during the test. Workers stay in an isolated safe room during the test, from which they can see the process while ensuring there is no danger. There are different types of crash tests, being the frontal impact test the most common one, in which the vehicle impacts frontally into a solid wall. In car vs. SUV frontal crashes, studies found that the odds of death were 7.6 times higher for the car driver than the SUV driver. Each crash test is very expensive, so the maximum amount of data must be extracted from each test. Roller bench tests are also very common in the automotive industry to check the actual behavior of a vehicle's powertrain. It is important to note that to rest all-wheel drive vehicles, an appropriate test bench that lifts all four wheels must be used. The car is fixed to the ground with a metallic bar to avoid it from moving in case it gets out of the rollers during the test. Many car manufacturers use camouflage vinyls when driving test cars that have not been revealed yet on public roads. Camouflage helps hide shape details like cuts and creases, contours on the body, etc., and in particular, helps blur out photos. Camouflaging started back in the 1900s when British soldiers wrapped their ships in black and white to make the size, direction, and speed of the ships unidentifiable. Batteries manufacturing is a very delicate process that must be carried out in a clean and dust-free environment. Focusing on lithium-ion batteries, which are commonly used in electric vehicles, the materials preparation process is the first step of assembly. Materials like lithium cobalt oxide or lithium iron phosphate are coated onto aluminum foil to create the cathode or the battery. Graphite is usually coated onto copper foil to create the anode, and a solution containing lithium salts is used as an electrolyte. Alternating layers of cathode, separator, and anode and filled with electrolyte, a battery cell is created. Depending on the design, cells can be cylindrical or have flat rectangular shapes, also called pouch format. Cells are grouped together in modules, and these modules are combined to form battery packs, which include electronics for monitoring and balancing individual cells. Cells undergo rigorous testing to ensure they meet quality and performance standards, including electrical performance, capacity, and safety tests. Electric vehicles' batteries are usually assembled on the bottom of the car to lower the gravity center as much as possible. Quality control checks are also performed on the assembled battery packs to ensure they meet safety and performance standards. Mercedes EQXX is equipped with various autonomous systems, which allows the integration of autonomous safety features. Pedestrian detection and protection systems can detect pedestrians near the vehicle's path and take action to avoid or minimize the impact. Similarly, autonomous emergency braking ABB can detect an impending collision with an obstacle or other vehicle and automatically apply the brakes to prevent the crash. All these features work together to create a comprehensive safety net to reduce the risk of accidents and enhance overall road safety. As a modern electric vehicle, the EQXX is equipped with advanced technology features, including driver assistance systems and safety features. EQXX features a design that aligns with Mercedes-Benz's luxury and modern aesthetics and incorporates the distinctive styling elements of the EQ family. Overall, the Mercedes EQXX is a vital piece of the Mercedes EQ family, with which the German brand tries to transition towards electric mobility.